we are going to be finishing up the 2016 STAAR Algebra 1 test. We're going to start with number 48. It says that we have a bag. So I'm just going to draw a bag. All right? That's a horrible looking bag, okay? It's more like a pop in a bag. But what does the bag consist of? Money. Cha-ching, right? So look what we have money in the bag. What do we have in the bag? $2.85. $2.85. So we have $2.85 in the bag. $2.85. All right, what else do we have in the bag? What kind of money is in it? What goes in? What? Quarters and dimes. Just quarters and dimes. Nothing more, nothing less. Do we know the total number of quarters and dimes? That's right, we do. How many quarters and dimes do we have in total? That's right, it tells us. Right there, we have 18. So what we're going to say on our paper is this. Write this down. In words. Quarters plus dimes equals 18. Now, if we were only given a letter to represent quarters, that would be very helpful. Does anybody know which letter?
Q.
That's right, it's the Q.
I just did that before. I didn't even write the words down.
All right, plus, if they only gave us a letter for dimes. Good. I like how they made it nice and simple. You know, Q and D. Q plus D equals a total of 18. Now, what we're going to do is we're going to look at, now, if we only knew the amount of cents that went with a quarter. 25, that's right. So we have 25 cents. Now, how do I write 25 cents? I'm just going to put 10 cents because I'm not going to insult your intelligence. All right, right here. All right, how do I write that as a decimal? That's right. So 0.25 times the amount of quarters plus 0.10 times the amount of dimes equals, if we only knew the total of all of it together. We do? What is it? That's right, 285. That's the total money, right? This is the total amount of dimes and quarters together. This is the total money. Now, do we even need to solve? No. All we have to do is just what? Set it up. And make sure that the 0.25 goes with the quarters. And the 0.10 goes with the dimes. And then together they add together to equal 18. That's why the answer is H. So this one, it actually didn't require you to solve. Now I'm going to show you guys how to solve it using Desmos. But we can't use Q and D in Desmos. What can we use? All right, so let's just make X the quarters, all right, and Y the dimes. And I'm going to show you guys how to use Desmos real quick, all right? Actually, what we're going to do, we're just going to type it in literally exactly as it is. All right? So we have X plus Y equals 18, 0.25 X plus 0.10 Y equals 285. So let's go to Desmos, all right? We're just going to type it in. So if they asked you to solve it, here's what you would do. You'd have to change it in terms of what? X and Y. 0.25 X plus. You can put this down in your journal. So like, oh, right. This is how you can solve. This is called a system of equations. We have not gotten to the system of equations part yet. We're going to soon. All right? Now, the system of equations is where the two lines, the solution is where the two lines meet. Can you guys clearly see where the two lines meet? So you just take your little mouse and you go pink, and it says what? 7 and 11. Now, what is that? What does 7 and 11 mean? It means the ordered pair is 7 and 11, which means your X is 7 and your Y is 11, which means in this particular problem, what did we say X represented? The number of quarters. So we would have a total of 7 quarters and a total of 11 dimes. Now, how could we check it to make sure it works? All you got to do is do what? Is 7 plus 11, 18. So that works, right? But if you did this in the calculator, you could do 0.25 times 7 plus 0.10 times 11, and what should that equal? 285. So So this is where you would just use your calculator, your whatever calculating device you're using, and type it in and make sure that it equals that. Okay? All right, so if we take 0.25 and we multiply it by 7 plus 0.10, you can put 0.1 if you want to, times 11. And what should that equal if we got it right? 285. Now, this problem did not require that much. All it required for you to do is set it up. All right. Now, we haven't done factoring yet this year, but right now, what we're going to do, we're going to show you a little concept. It says, which expression is a factor of this? All right? Now, let me explain to you how you would do it by hand. All right? So x squared minus 5x. I think you guys, when we get to factoring, you're going to like it a lot. All right? It's not too bad. Basically, when you factor, you're going to have two binomials that multiply together to equal this product. And you're looking for two numbers that multiply together to equal -6, and two numbers that add together to equal -5. Now, we only have a certain number of factors of 6. What are the only factors of 6? 6 times 1 and 2 times what? 2 times 3, right? Well, what do they have to multiply together to equal? A -6. All right. Now, we have 2 and 3 can get us to a -5, right? But they both have to be negative. What's a negative times a negative? Positive, so it's not going to be a 2 and a 3. The factors are going to be x minus 6 and x plus 1. Because -6 times 1 is a -6, and -6 plus 1 is a -5. And we're going to have a whole section on practicing factoring. We're going to get really good at it. Okay? Now that's what they want you to do. It says, which expression is a factor? Well, what's our answer in this particular case? X minus 6. Well, let's say you're taking the STAAR test and you're like, you know what, I am just going blank. I don't know what to do. I don't know how to find the factors. What do I do? So here's what you do if you don't know how to factor. You take, I'm going to clear this out, I'm going to take x squared minus 5x minus 6. Now this is what I want you to pay really close attention to. Does everybody see a 0 here and a 0 there? The zeros of that parabola, where it crosses the x-axis. This is what you got to look for. All right? Now, check it out. Watch what happens when I hit x minus 6. Where does it pass through? It passes through 6. See, it passes through one of the zeros. All right? So, your answer choice will pass through here, or it'll pass through there, right along the x-axis. That's what you need to remember. Now, let me look at some of the incorrect answer choices. What's one of the incorrect ones? X minus 2. Look what happens when I type in x minus 2. There we go. If I go over here and I type in x minus 2, does that pass through this point or this point? No. All right, what did I say the other answer choice was? X plus 1, right? Look what happens, though, when I type in x plus 1. It goes through what? It goes through the other 0. So what are your answer choices going to do? They're going to pass through either this 0 or this 0. So in review, if you have this problem, if you don't know how to factor these, type this into Desmos and find which one does what? Passes through the 0. Passes through. And does everybody know what a 0 is? Wherever that parabola touches the x-axis. That's a 0, a root, or a solution. That's a 0, a root, or a solution. Those are words that mean the same thing. All right. Okay, we're going to have to zoom out a little bit. Okay? Let's read through it and then we'll zoom out. It says, the number of stores opened by a coffee company can be modeled by the exponential function graphed on the grid, where x is the number of years since 1992. All right, so let's see what's happening. Number of years since 1992. So these is just like 1993, 94, 95 going up. What's happening to the number of stores? linearly, but exponentially. It is going up super, super fast, okay? Now, what we're having to do is it says, based on the graph, which statement does not appear to be true? So when you're doing these problems, make sure you don't look necessarily for the truth. You're looking for what is not true. All right, so let's see if these statements are correct. The coffee company had opened 400 stores by the end of 1992. Well, right here, if this is the number of years since 1992, how many stores did they have in 1992? So does that statement appear to be true? Okay, so I have to check that that's true. All right. The coffee company opened up 100 stores in 1 year. All right. In 1 year, it looks like they did. That's possibly. All right. That did happen. Looks like in the first year they went up from what, 400 to 500. So that appears to be true. That doesn't. All right. Let's see here. Every year, the number of stores opened increased by 25%. Let's check. Let's find some points. See that point? Right there? That's at what? 1,200? Let's find another point. That'll work right about there. Let's make a little table. So what do we do right now? Here's what you can do. Exponential functions make a table. Alright? We're going to make x and y. These are the x's, these are the y's. And what I want you to write down for your exponential equation is this. So write this down. Y equals a times b to the power of x. So write that down. Y equals a times b to the power of x. We're doing, what did I say we were doing? Exponential. We have not done that this year. This is going to be something we're going to do in Algebra 1b. Okay. Exponential function. Yeah, the second part. Okay? Alright, so here's what I want you to label. Label A as your initial. That's your initial number. Like what you start with. Okay? And B is what's called your growth or decay factor. Alright? And then X is just the number of years. Okay? And that's Y is your result. So right now, if it increased by 25% every single year, here's what would happen. You can say Y equals, how many stores did we start out with? We started out with a total of 400, so you put Y equals 400. Now, if it increased by 25%, here's what you're going to have to do. You're actually going to have to put 1.25 for 25%. Now, 25% is 0.25. But if it increases, you have 100% starting out. And what are you going to add every single year? You're going to add 25%, and that gets you a total of 125%. And how do you write 125% as a decimal? 1.25. So here's what I want us to do. Go to your graphing calculator, right? Go to your graphing calculator. I want you guys to type this in with me, okay? And what we're going to do is we're going to make a table. We're going to make a table 0, 1, 2, 3, 4, 5, 6, all the way up to, we'll make it all the way up to 8, 7 and 8. So we're going to have Y equals. You're going to type in 400, because that's what we started out with. Alright, we're going to type in 1.25, which is going up 25% per year, and we're going to raise that to the power of x. We're going to check our table. Alright, so here is our table. 0, 400, 1, 500, 2, 625. Okay? So right now, what I want to do is I want to check right here. You guys have that? Help me out. Write down what we have. We have 0, what? 0, 400. Then look at your table. We have 1, 500. So that went up by what? 100 that year. What's 2? 2, 600? No, it's not. to 625. Anybody else have that table in their calculator? Where's 3 going?
781.25.
781.25. Next one.
Number 5 is number 4. 976.56.
976.56. All right. 5.
5 is 1228.7.
And 6.
1525.9.
1529. 1529.9.
Yes.
Well, it's jumping up by 25%. Let's right here at 5. We're at 1220. What's it at 7?
1907.3.
1907. So 7 is 19. It's following pretty close. And then 8 was at
2384.2.
2384. All right. So 8's at 23, which is pretty close to that. Okay. All right. Now, if it's going up, I want you to notice that these points are really close to these points right here. All right. Now, it is increasing by 25%. Otherwise, it wouldn't follow this pattern. Okay. But if it says right here, since 1992, the coffee company has opened 250 stores each year. That's not an exponential function. That's a linear function. If it goes up, what would that be? That'd be your slope. That'd be y equals, the equation for this would be y equals 250x plus 400. Where are you starting at? 400 stores. What's it going up each year? 250. This is linear. All of these others are actually true. The only one that's not true is J. So what you're going to look for, if it says it's an exponential function, find something that's not true. Basically, search for the linear function. Search for the part that is showing that it's going up as a constant rate of change, not an exponential rate of change. Okay, everybody should know how to do this. All right? We should know how to do this. All right? That's your x1. That's your y1. That's your x2. That's your y2. All right? And what's it asking for? Slope. What I want everybody to know how to do is do this. You can write down those ordered pairs and check it. I'm going to pause the video. You should know how to use your slope formula either this way. I'm going to show you 3 different ways to find it. This is the by hand way. Go ahead and try the by hand way by labeling things out. You'll have this formula. So take your time, write things in. I'm going to put y2, y1, x2, and x1. So go ahead and do that. All right, let's see what we get. Right here, if you do 12 minus 7, you should get a 5. Okay? And if you do negative 39 minus 26, that's negative 65. And that reduces to negative 1 over 13. That's the by hand method. All right, if you just did it by hand and you knew how to add and subtract integers and stuff like that, you get this. Now, here's what you would do in the graphing calculator. Okay? You would hit Stat, Edit. You go over here to L1 and L2, and we type in our x values and our y values. So, what was our ordered pair for our x's? We go back, it was what? 26 and a 7, so you type in 26. You type in over here a 7. Remember, it's got to be x, then your y. Okay? Go over here, we type in negative 39 and a 12. So we type in a negative 39 and a 12. Then you hit Stat, right arrow, go down to number 4, and it's going to be in the form of y equals ax plus b, and you're like, what in the world? How am I supposed to, what answer is that? That's my slope. What does this represent? Your y-intercept, right? Okay? Well, check it out. If I type in Remember that number. -1 divided by 13. What's the decimal that goes with it? That decimal right there. So you can check your fractions and see which fraction matches the decimal. Okay? In Desmos, I'm going to clear this out, clear this out, clear this out. What can we do? We can make a table. And tell me the ordered pairs again. Help me out. 26, 7, -39, and 12. Okay? Now, in order for this to work, you have to remember this. Y1. Squiggly line. M. X1 plus E. We gotta find B. Where is it? Right there. Ha. See that ridiculous decimal? So you have to be able to check, use your calculator to check which one it is. That gives you your slope and your y-intercept. Then you can go back up here and switch these numbers around and find your new. But what's the phrase that pays? This is the phrase that pays right there. You got to remember that. Can I remind you about that while you're taking a test? No, you got to remember it. I can just look at you and say, just do the best that you can.
You can write it on your hand.
No, you cannot. All right, so here we go. No, no.
It's in a raven.
Now listen up. We're going to do this by hand. All right, we're doing number 52 by hand. And I'm going to show you how to use decimal. So here we go. First thing we're going to do is you're going to write that down. First thing we're going to do is we're going to distribute. Okay? So you're going to take 0.3 and multiply it to 12x. And if you use your graphing calculator, you should get 3.6x. All right? Minus, if you do 16 times 0.3, you should get 4.8 equals. Over here, if you have 0.4 times 12, you will get another positive 4.8. And if you do, distribute, okay, and distribute this. 0.4 times negative 0.3 is negative 1.2x. Now when you're solving these, okay, when you're solving these, you got to get all the x's to one side and all the numbers to the other. So here's what I'm going to do. I'm going to add 1.2x to this side. We can throw it across. Whatever you do, whenever you throw something across the equal sign, it always becomes the opposite. So we add these together and we get 4.8. Over here, how do I get rid of the negative 4.8? I have to add 4.8. Or you can just take it and throw it across the equal sign. And if it's a negative, it becomes a positive. Now this zeroes out. These add together to get 9.6. So what are you left with? 4.8x equals 9.6. What are we going to divide both sides by? That's right. Divide both sides by 4.8. 4.8. And what is x equal? 2. That's your answer. Okay? Now that's how you do it by hand, right? Now how could we do this in Desmos? What we're going to do in Desmos is this. Check it out. I want you to understand we're going to take this and put it in one side, in one expression. And we're going to take this and put it in the other expression. And we're going to find where those two lines meet. So can you guys remember this? Remember this. We're going to go to Desmos now. Here we go. All right, I'm going to go ahead and clear this out. Clear this out. Here we go. I'm going to type in, what's our first expression? 0.3. All right, so here we go. I'm going to type in 0.3. Open parentheses.
12x minus 16.
12x minus 16. And what is it to produce for us? A line, right? Go down to the next one.
0.4.
0.4. Open parentheses.
12 minus 3x.
12 minus 3x. Look, where do they intersect? What's the x value? Not the y value. What's the x value where they intersect?
2.
So all you have to do is put one in here and the other in here. Find where those two lines what? Meet. That's it. All right. All right. This should be enough. Okay? Now, you don't have to draw all these, everybody. You can just, I want you to pay attention right now and take a very good hard look at what it's asking us to find. It says, which graph represents a function with a domain? Just remember, domain deals with what? Left and right. So here's what I want you to do on your paper. I want you to draw arrows going left and right if it represents the domain. So we're going to find the domain of all of these together. All right? We're going to find the domain, and that should let us know what the answer is. There we go. The domain is how far it goes from left to right. This says, which graph represents a function with a domain that what? Is greater than or equal to -7 and less than 2. Greater than or equal to -7, that means the circle is closed in. Less than 2 means it's open. The answer is going to be answer choice D for this one. Okay? Alright, so right now, listen up. Right here, this answer would be x is less than or equal to 7, but it's greater than -2. That's how you would write this one. Anytime you see open circle, that means not equal to. Anytime you see closed in circle, that means equal to. Alright, how far to the right does this get? It gets all the way to a 1. How far to the left does it get? All the way to a -4. My x value is less than 1, but it's greater than or equal to 4. That's how you would write this domain. This domain that we did, the answer choice, x is less than 2, but greater than or equal to -7. Alright, and go ahead, pause the video and see if you can come up with the answer for B. So look at B and see if you can figure out what expression right here, what inequality expression would be for B. Alright, so the final answer for this would be x is less than, what's the greatest number that it gets to? A 2. Notice I didn't put an equal sign because that's an open circle. And greater than or equal to -3. Why did I put the equal sign? Because that's a closed-in circle. Now every single one of these answers represented the domain. Now what would the range be? I'm just going to give you one example if they switched it up and said, what would be the range? Okay? So if it said, let's cross this off real quick. What if I said, which graph represents a function with a range of all real numbers greater than or equal to -7 and less than 2? Okay? I'll show you which answer that would be. What did it say? Greater than or equal to -7 and less than or equal to 2. The range doesn't deal with the left and right. The range deals with the up and down. So if you interpret it, how high does it get? It gets all the way up to a 2. How low does it get? It gets to a -7, and it's actually touching right there at -7. This would be the answer for y is less than 2, but greater than or equal to -7.
What about B?
So it would be. Actually, B would be wrong because it's less than or equal to 2. And great, so B, here would be the answer for B for the range, right? How high does it get? All the way to a 2. How low does it get? All the way to a -7. So this answer would be y is less than or equal to 2, but greater than or equal to -7. That would be the range. So if I switched the word from what? Domain to range, then the answer would be answer choice C. Okay? So it's either the question is going to ask you about the domain, which in this particular case is answer choice D, or they're going to say range, and then the answer would be C. So you got to be careful. You got to know what it's asking for. Is it dealing with left and right, which is domain, or up and down, which is range? Okay, here's the final one. What I want you guys to do. I want you guys to put this in your journal. Just draw the picture and everything. We're going to do this step by step. This will be the last one that we do. All right, today what we're going to do is we're going to practice the FOIL method. Okay? Now it says the diagram shows the floor plan of a storage facility. All the dimensions are given. We have 5x plus 4, which is a binomial. 4x minus 4, which is a binomial. It says which expression represents the area. How do you find the area of any rectangle? You should all know. That's right, length times width. That's it, length times width. Alright? Now a box would be length times width times height. That's a rectangular prism. This is just length times width. So let's just call this the length and call that the width. So we're going to take 5x plus 4. And we're going to multiply it to 4x minus 4. So we're going to call this the length, and we're going to call this the width, and we're going to multiply them together. We're going to use what's called the FOIL method. Alright? So here's what I'd like you guys to do. I'd like you guys to write F O I L. Just like that. F O I L. We're going to do this a couple of different ways. Alright? We're going to call this first. I may have outside, inside, and last. First, outside, inside, last. Okay? So we're going to take our first products. Our first products are right. First products are what? 5x times 4x. And what does that give us? 20x squared. Okay, I'm going to change color now. Now we're going to do 5x times a negative 4. 5x times a negative 4. And what does that equal to? Negative 20x. Okay, switching colors. Now we're going to work on the inside numbers. These are the inside numbers. What are our inside products? What two numbers do we multiply? 4 and 4x, which gives a total of what? 16x. Good. And finally, we're going to do our last products, our last numbers. Close. 4 times a negative 4. And that gives us a what? Negative 16. Now, what are the only things that can actually, or like terms that can be combined? The only thing that we combine together is a negative 20x and a 16x. So what does that give us when we take those and we add those together? It gives us a negative 4x. So what is our final answer? 20x squared minus 4x minus 16. Okay? And that's our final answer, which is answer choice G. Now, here's what I want you guys to do. Maybe some of you guys might like the method I'm about to show you. So, if you would, please put this in your journal. Here we go. I want you guys to create a box. If you would, please create a box. All right? So I'm just going to make a square. Okay? So make a square like that. Okay? And what we're going to do is we're going to separate the square. All right? Into 4 pieces. Okay? So just try to do your best to kind of take that square and separate it into 4 pieces. Right? What I want you to do here is I want you to put a 5x and a positive 4. And I want you to put a 4x and a minus 4. Just like that. Alright, if you're wondering where I got the 5x and the 4, I got it from here. 5x, and that's a positive 4. And then I used the what? 4x and a negative 4 and put it right here. Now, what we're going to do is we're going to find the area of each of these little squares. What's 5x or rectangle? What's 5x and 4x? 20x squared. What's 5x times negative 4? Negative 20x. What's 4x times 4? 16x. And what's negative 4 times positive 4? Negative 16. So this might be an easier way to organize your information, so that you don't have to do all the rainbows or the distributive property we're talking about. You don't have to worry about, okay, did I do everything that I needed to? If you make everything and you put it in a box, then what should you have? The 20x squared. What are these going to add together to equal? Negative 4. What's that going to be? Negative 16. Okay? Now, listen up. Here's the last thing we're going to do. We're going to show you how to check your answer in decimals. Now, how do we check this in decimals? Check it out. We're going to take open parentheses, and it was what? 5x, was it plus 4? 5x plus 4 in parentheses. And then we're going to do what? 4x minus 4. And look what Desmos creates. It creates a graph. What was our final answer? 20x squared minus 4x. What's the final answer? Minus 16. Look what happens. What do you notice? This was our original expression before we FOILed it out. This was our final answer. What happened? These graphs are the exact same graphs. Look what happens if I type in the wrong answer. Give me one of the wrong answers. What was one of the wrong answers? Oh, you don't. That's right, you don't have it. Hold on. I'll look at the wrong answers. All right, how about this? 20x squared plus 36x minus 16. All right, let's write that down. All right, here we go. 20x squared. I think it was, what was it, plus 30, plus 36x. And then minus 16. And look what happens. You get a graph, but it's not the exact same one. So all you gotta do is type all the ones that are exactly the same. Like type them in and see which one is the exact same. Now, what do you have to know how to do to get this problem right? You have to know how to find the area of a what? Or a rectangle, right? Length times width. That's what you have to know. Alright, well that's the whole test. Done. Step by step. Hope you know how to use your calculator in Desmos and know how to do it by hand.
All rectangles for
All squares are rectangles, but not all rectangles are squares.